The world is generating more data every day, and that data is coming in faster and in a greater variety of formats than ever before. It can be hard to keep up. The data comes from a variety of sources, such as multi-cloud, SaaS apps, and on-premises solutions. Ingesting and transforming all that data quickly and consistently can be a challenge that leads to costly bottlenecks. But there is a solution. Azure Data Factory is an easy-to-use, cost-effective, powerful, and intelligent cloud-based solution for accelerating data integration and transformation. Azure Data Factory lets you easily integrate and transform data with just a few clicks. Rehost your on-premises SSIS packages to the cloud in record time and construct native code-free ETL processes at scale on Spark. With Azure Data Factory, you reduce costs because you only pay for what you use. Azure Data Factory is a fully managed serverless cloud service that scales on demand and addresses your ETL needs with one powerful solution. Use over 90 plus built-in connectors to ingest and transform all your data wherever it lives. Leverage intelligent, autonomous ETL to realize greater efficiency. Empower citizen integrators and deliver your integrated data to Azure Synapse Analytics to unlock limitless insights. In short, remove the bottleneck and embrace a solution that's easy to use, cost-effective, powerful, and intelligent. Focus on your data and let Azure Data Factory do the rest. Get started with your free account today.
Sounds really cool. Hey everybody, welcome back to AzureFunBytes. My name is Jay Gordon, and every week what do? We get together, we have a conversation about all the different services, products, and everything else that goes into you having an amazing Azure experience. So, I've talked a little bit about this on Hello World, and I want to thank everybody from the team over at Hello World about Azure Data Factory. We quickly kind of just hit on what it is and what it can be used for. But you know what? I'll be honest, I don't know enough. And while I can go and I can find places to do all this, I find it always better to work with people who are the experts at, I guess, the content that we have to talk about. And so I'm going to bring in an expert right now. Hey, Mark. Welcome to the show. It's Mark Kromer from the Data Factory team. How are you today?
Hey, Jay, I'm great. Thanks for inviting me on. It's great to have the opportunity to talk to you about Data Factory.
Great. I'm really thankful that you're here today. You're a principal product manager. You've got a lot, or is it program manager? Excuse me. Product
one or
manager.
The other doesn't matter. Just say PM.
Yeah.
That way you don't have to worry about it. Principal PM.
And you've been kind enough to join us here on LearnTV, where we come and we get together. And so there is something really cool going on. Mark, I know you're going to be checking it out. It's Microsoft Build. And so I want everybody to make sure that they've registered for Build. But in the meantime, just let me know if you have or you haven't in the poll. Go ahead to aka.ms/LearnTV, take the poll. Even if you're watching it on YouTube or you're watching, on Twitch or Twitter, it takes you just a second, hop over and take our poll. And Mark, I've got so many questions to ask you today. And I know that our audience is going to have a ton as well. So I want to remind everybody and go to the chat, your native chat, whichever one you're using, and send us your questions that you may have about Data Factory or big data in general. And you know what, Mark, I want to get started. And before we hop into Data Factory, let me ask you, how'd you get here to Microsoft and how'd you get into what it is you're doing nowadays, which is talking to people about how to best utilize their data?
Great question. So, yeah, it's been a journey, that's for sure. I've been in the data space for a long time, for a couple of decades now, and so I've always had a lot of interest in how businesses use data and make it valuable. Right, that's always been a very interesting thing to me. From working with databases, back in the day, to working with business intelligence, and this space in particular with Data Factory, which is ETL and data integration. Something that I've done for a long time, and it's something that I have a lot of interest in because I think it's really interesting to find how you take all that massive amounts of data that you have throughout your ecosystem, and how do you turn that into value. That same value proposition is prevalent in business intelligence tools as well, but that's the personas that use that are typically business analysts, business experts, those who know the business really well and are Excel users and Power BI users. But for me, I've always kind of played at that sort of data engineer level where we work with massive amounts of data. Data engineers are on the hook for bringing value to the business by making sense of all that data, or at least putting into formats in ways that then those business analysts can mine that data for valuable insights. So that's how I got to where I am. I've been doing this kind of work at Microsoft for 11 plus years now, and in Data Factory for a little over 4 years. And what I really like about it is to be able to see our customers gets real perceivable, tangible benefits out of using a tool like Data Factory. I can remember back when I used to work on SQL Server integration services or SQL Server, and back in those days, that was really the ETL tool for Microsoft. And I remember talking to customers who kind of started to at the end of the last decade wanting to move everything they have from their business data and all of their data assets into the cloud, and thinking that seemed like something that was far from the future and that would never happen. And now look what we have today. We have this tool that we'll be talking about today, the service of Data Factory, which is completely data integration, moving data around in massive petabyte scale.
Yeah, that
Massive
kind
amounts.
of. And so you've got a data pedigree, if you will. You
Yeah,
spent
for
some
sure.
time at Pentaho, which I know is a tool for big data analytics. And,
Yep.
I was over at MongoDB for a little while, and I
Yep.
remember all the people talking about the integrations with that. I know you were
Yep.
over at DataStax for a little bit. And then you made your way back to Microsoft
Yep.
after that break, and have really helped people get the most out of their ETL process. And
Yeah.
so I'd like to start kind of like talking a little bit about what Data Factory is in the grand scale. And I think that this slide kind of helps put it all into perspective. We're talking about code-free ETL as a service. And so, Mark, if you don't mind, can we go over a few of these like big topics here? Ingest. So I'm guessing that ingest is referring to how we bring data in, correct?
Yeah, so these are kind of the pillars of Data Factory, and that journey that we were just talking about. It was an important setup, and I like the fact that you started there because when we worked with tools like SSIS, the on-prem tools in the day, being able to do this in the cloud, completely fully in the cloud, seemed like a far off pipe dream, and that's exactly what you see here. You see ingest, the ability to have a control flow capabilities, kind of what you have in SSIS control flow. Data flow is transforming that data, sealing all of your operations, the actions you take on that data, the data integrations, the ETLs, and then being able to monitor that. That's a full spectrum ecosystem for an ETL tool, and that is all completely platform as a service, serverless, like you said earlier in the intro video. It's completely something that's managed by Azure. All you do is you come into the tool, and we'll show that in a little bit here, and you build your logical intent. It's meant to be a low code, no code environment that you can do those things that you had in the slide. And ingest is the most important probably in all of that. It's the thing that happens the most often is you're moving data into Azure, and you can use Data Factory to do that. And then you can move it around the different areas of the fabric within Azure into different services. Yeah.
So this is the big idea that I got from this service, that our ETL process, which, I can't imagine it's easy if you're talking about, not just gigabytes of data, but, terabytes and petabytes. So when you're talking about data at scale, you really run into some very, very like typical internet bottlenecks. The rate of transfer based on, network traffic. You're talking also about CPU and memory availability on the source systems. Uh, how are users getting something that Data Factory does done beforehand?
Yeah, I think the mechanisms used to achieve those things and to accomplish that, without Data Factory, is you essentially have to provision and stand up compute and storage and pipes and everything else that you need to be able to move that data around on your own, and you're responsible for that. And what that leads to is long cycles. It leads to lengthy time to acquire hardware, to acquire resources, to manage those resources. And then in addition to that, you have to then be able to put that into a sustainable system, one that can constantly do this, right? Because when you're moving data, it's in most cases not just a one-time action. It's something that you need to do on a daily, sometimes hourly, sometimes even less than that kind of basis. So you'd have to usually over provision. So you'd see a lot of customers in the past would over provision, say that they knew that they had a terabyte of data every day they had to move, and they're thinking to themselves, "Oh my gosh, I want to be able to provision enough compute to do that. But how is my business going to grow in the next 1 to 2 years?" Well, they're going to then multiply that by 10 or some kind of factor of that nature, and then over purchase and over provision. So that's
Mhm.
why the cloud is so important for data integration, because then you use the serverless capability like a Data Factory brings to the table. And then you just say, here's what I need to, here's the sources I need to get in. Here's what I need to do with those sources. And then here's how I want to land it. And then we can handle in Azure the scale that you need for that. And so because we operate at petabyte scale, you don't really need to worry about those things. It lets you focus on the primary business goal of what you're trying to do, which is to get that data into business decision makers' hands in a way that allows them to make better decisions. And yeah, the massive amounts of data, moving it is the first most important part to that.
And one of the things that I really like about this is, like, while you don't need to know how to write code to actually accomplish this, because you call it a code-free process, there is CI/CD support for this service. And so I believe that you can store your configurations that you're doing in Git and be able to reference those and, I guess, use them in multiple data warehouse situations. Am I right there?
Yeah, absolutely. Yes. So the vast majority of our users in Data Factory are ETL tool users and data integration tool users. So they prefer that visual diagram, because here's the thing, right? Is that data engineers are just ridiculously busy folks, right? They are
Mm-hmm.
overwhelmed by the amount of work that they're given by their teams and their business, and it's a good thing because it means they're important. It's also a burden because there's so much work. So they enjoy that sort of environment where it's a one-stop shop, single pane of glass. They don't need to write code to do everything. Um, at the end of the day, the Data Factory definitions and the transformation definitions are all stored as code. The UI is a helper to be able to do that without writing that code. And so it's all stored, like you had pointed out there, it's all stored in repos. And we abide by the Git process. So you create branches and you merge and you do the PRs, and the whole Git process is fully supported. In addition to that, it's also important in that sort of ecosystem is that we fully support the coders as well. So there are also organizations that have folks who are deep data engineers that are also data developers and write code for that. So you
Mm-hmm.
have the option of writing the code if you wish. We have full APIs, SDKs for it. And also, if you want to write transformations yourself, you can do that too. So that's fully supported
Yeah.
as well.
I brought up this thing right here. Let me see. There it is. I
Yeah.
brought this up because this kind of shows the workflow of if your working branch,
Yeah.
your published branch. It goes into release management, and we've got documentation. I've shared it just a second ago about how to get this all done using Azure DevOps, which I think has got some built-in integrations for using the ETL process with Data Factory. So I believe that where it goes is that you trigger maybe some changes to how the pipeline looks. That pipeline then, like I said, it triggers a process and says, okay, we've got something new in our main branch. Let's go ahead and execute it. And then I would imagine it calls the API over to Azure and kicks off the process.
Yeah, that's right. So you can, we support both DevOps and GitHub. And yeah, that's right. So the Git process is pretty much the same in those. And so what happens is you pick the tool that you want to, the repo you want to connect into in either of those services. And then regardless of whether or not you're writing the code or using the UI, it is all fully integrated in it. So it supports CI/CD. So you can continue to implement your changes. And then you can gather those up into a branch. Then when you're ready, you can publish those to the service. So what that allows you to do is it allows you to work in sort of a sandbox environment. You can build your ETL code, your ETL pipelines, your processes, test those out of band, test those outside of being in the production branch, and then you can, when you're ready, you merge that into the master branch. And it absolutely is a really powerful way. Now, a lot of times data engineers, this is a little bit of an unusual environment. The Git environment is more of what developers use for writing code, and so we sort of bring that into the fold natively with ETL and ADF, and it's a very exciting feature. It's one that I think is very, very preferable for our users to use, because it gives you that ability to make sure you've tested everything. You collaborate with the other data engineers on their branches, and then you can merge those together. So it's a extremely powerful feature.
And the other thing that I saw is that you support a number of different data stores to actually use as where you're sourcing your data, or even where you're putting it. Yesterday, I kind of worked through a process of that. We have a really good piece of documentation about how to get started using Data Factory and ETL. And one of the things that I did was, created a text file with some names and values, and then eventually put it into a piece of blob storage or a blob container, and then take that blob container and connect it as a link device. Then I created an SQL server, created that as a link device, or link service, I should say, and then went ahead and actually created a process where it was just punch the button and the data moved from one place to the other. And I guess, it was just a little bit of data, but I would imagine if you're talking about just thousands or millions of records, this will help really kind of simplify the process.
Yeah, that is the core sort of use case and sort of flow that we wanted to be able to make really easy, right? When we first developed Data Factory, Azure customers coming on board to Azure, saw a portal with a plethora, a large menu of different services, and it wasn't necessarily clear how to get from one thing to the other. So Data Factory kind of provides that pipeline that connects those things together, and so you can take your data from not just inside of Azure. We can take your data from on-prem, and we can port that and migrate that into Azure with Data Factory. So once that data is in Azure and in the fabric, then you do that. You make your choices of where do you want it to go. A lot of times, pipelines have multiple different kinds of landing locations, what we call sinks, in there. And so we make it super easy to just pick a type of store you want to land it in. So in your case, it was blob store. You may want that to be, if it's going to be files, blob store ADLS Gen 2, perfect for that. If you want it to be in a relational database, then Azure SQL Database would be probably the place you want to put that in. We also have MySQL, Postgres, all of those. We have more than 90. I believe we're almost at 100 different connectors now. And this is a really common thing you'll see in ETL tools, is that the connectors is really what lets you expand your pipelines, the things that you build, because now you can connect to all these different sources and sinks and origins and destinations. And then with Data Factory, we just continue to innovate on these. We continue to add more connectors every month. Is pretty much our cycle is monthly on these. And as they land, they just light up in your UI. You just you see it there, so you don't have to go and purchase anything new or go to a marketplace and ask for something. Although we do like to take requests for other things you want to see. But yeah, this is that list here. And these are all the things that you can
So many databases. And here's the other part where I think it's really cool is that NoSQL integration is that NoSQL has really taken off, especially because of the flexibility to be able to index on almost anything. And so it's really cool to see that, I could actually transform some of my data that's in, say, NoSQL, probably over to one of those SQL databases, if I wanted to do that, and actually have mappings so that my values match between the two different databases, because not everything is going to work with NoSQL. There could be some processes, and you don't want to use something that does, say, like real-time translation. I've seen these connector tools, like especially with Mongo, that it makes Mongo speak SQL. I'd rather the data just get transformed, to be honest.
Yeah, that's a really common pattern in ADF because, like you said, the NoSQL databases, we have connectors for Mongo and Cosmos DB and whatnot. And you mentioned data stacks earlier, so Cassandra as well, right? Really common NoSQL database. And in those cases, because they're becoming more and more prevalent, that just naturally becomes part of your data integration ETL job and thing that you do. So even if you don't know those systems really well, you connect to it with the connector and you really just point to the database, and then we consume the data. Now, like you said, we allow you to very easily convert and transform what we call relational to hierarchical and hierarchical to relational. So either way you want to go, that's fully built in to Data Factory. That's a really common pattern that our users do in Data Factory, because when you're in a lake in cloud environments, you're going to have almost no guarantees in terms of what that data shape is going to look like. And I'll be quite honest with you, this stuff changes day to day. It makes the job of a data engineer really difficult. So we have built in these features in Factory that we call schema drift. So as that shape changes and that data changes, your ETL processes aren't built in a brittle manner. They're built to be resilient, so that it can accommodate for those changes. And if you take the MongoDB example, if you have your data stored in JSON, I think they used to call that BSON or whatever, but if it's kind of like that JSON format, it's hierarchical. Binary JSON, right? You take that output coming from your NoSQL, and then you flatten it out. So if you want to put that into maybe a CSV, or put it into your SQL database, we give you options to say that take this hierarchy, flatten that, take this array and denormalize that, right? And so that data can become, go ahead.
Yeah. Oh, sorry. Yeah, because I can see we've got all these even just data formats that are just text. Just process text. So, even if you're not pulling things from a database management system, or on one of these NoSQL services, if you've got some logging, you know what I mean, that's logging things into JSON. The fact that you can just say, all right, let's dump this log into a database so that we can query so we can maybe know things like, one of the big use cases that I've always heard of is when you're talking about e-commerce and how you're tracking how your users are actually going through your stores and finding out why they didn't complete purchases. And I think like being able to query that information from something as raw as just logs is really important, because we can talk about this, is that how important is this for business intelligence nowadays? Because that seems like it's a big part of what CIOs care about.
Yeah, it is. And it creates a new angle, a new twist on what the ETLer and the data engineer does in their daily job. Because before we had those sort of things, those logs and IoT and whatnot, with the different kinds of formats, the formats that really focus on velocity and change over standards and staticness, right? The dynamicism of the lake really changes the game quite significantly for data engineers. And so that's why a modern tool like Factory is built for that. Because what happens is, if you're going to read logs and you're going to add that to your business intelligence, you're going to need to really zoom in on specific things there, because those are very noisy. Logs tend to have a lot of noise in them. You need to be able to find that, you need this array from this hierarchy. You need to flatten that, and then you need to aggregate it and then add it and adorn it to your data. Legacy ETL tools did not do this really well, because the assumption was that ETLers were always working with standard sort of database tables, right? And those things just almost never changed So you're able to build like an ETL process or a package that you'd build one time, and then it just stays that way for months and months or years and years, and that's just not reality anymore, unfortunately. I mean, if you're connecting to your Dynamics or to your SAP, that probably is the case, but that's more the 20% rule now. When you're in the lake, you're going to be getting data feeds from all those different places that are going to have data of that kind of hierarchical format, and that's going to be changing from day to day. So yeah, that's a very important aspect to it.
And you talk about the lake. I think that the services are so required nowadays to be able to take on like this gigabyte, petabyte, terabyte scale. And so it'll feed really well into kind of the next part of our conversation. Eventually your demo is how do you take this data and turn it into information with safe analytics?
Yeah, it's a great question. So this is where we bring to bear with Data Factory a number of different things. We talked a lot about the data integration piece and the pipelines, the building the control flow to be able to say that these are the files and these are the database tables you want to bring into Azure, and that totally makes sense. Now on the big data and the data analytics side, and when you're in the lake, you need to have a way to be able to transform that data, be able to change the shape, aggregate it, summarize, do some data quality work on it, do some data cleansing. The data in the lake is by nature has low data quality, poor data quality, and so you're going to need to transform the data. Data transformation will do that sort of data analytics for you, and the way to do that at scale in the lake is to really use a Spark environment, a Spark engine for that. And so what we've done with Data Factory is we use a capability that we call as the Azure Integration Runtime, and that is surfaced to you with every factory you have. And that integration runtime defines the essentially the compute environment that we're going to use. So you don't have to worry about building a Spark cluster. You don't need to worry about managing a Spark cluster. This is completely serverless and managed by Azure. You just tell us what you need to do with your data. So if you need to aggregate your sales or weather data across years and years, and you need a large compute to do that because it's going to be just terabytes of data. Focus on what the math is and the statistics are that you need to get out of that. Build that intent in the graph. Okay, you build a graph in our tool, and then we will execute it on the right sized cluster for right sized compute for you. So the Azure Integration Runtime does that, stands it up. It's ephemeral. It stands it up just in time, executes your code, and then it tears it down. So the cost is very much in line with just what you're actually computing. So you don't need to have a cluster that is sitting around idle, running all the time. That's the nature of a serverless, which is what the integration runtime provides.
Great. And one of the things I want people to know is that if they want to start learning about how to utilize some of these processes of, doing integration at scale with Azure Data Factory and then being able to use Synapse to process it into analytics, there's this Microsoft Learn module. I really recommend you check it out. I went through it and it gave me a little bit more insight. There's also tons of other information available on Build, or I should say on Microsoft Learn, tons of docs in general about all of these processes and services that help you take your data, transform it, or I should say extract it, transform it, and load it. So, Mark, we're about almost a half hour in, and I just wanted to remind our viewers of one more thing. If they'd like to ask questions, they can put it right there in the chat. We'd love to hear from you. We want to know what you think. You go ahead, tell us what you'd like to know. And then, of course, I'm asking you all, are you registered for Microsoft Build yet? Got anything interesting going on for Build, Mark?
We are working on some sessions and demos and things like that. There's work going on for it. We're trying to line that up for sure.
It's a big week. It's just 2 weeks away. Yep. And make sure if you want to, it's another free event that we're doing. And so I really recommend you check it out.
Yeah, that's awesome.
So Mark, we got a half hour left, and I think that's enough time to give you to kind of show off what it is you've been describing, because we've talked a lot about what it is, the benefits, things like that. But you got something to show me?
Yeah, let me set my screen up. Let me know when this is sharing, and I'll get started with a
Yep,
quick walkthrough here.
you are live.
All right. So thanks, Jay. So let's do this. Let's let me see if I can kind of level set or baseline for you Data Factory from a tool perspective, from a user interaction perspective. So when you build your first factory, where are you going to start, and how are you going to do some of the exciting things that we talked about? And that all kind of points out where all these things are located that we mentioned in the discussion that we just had. So if I have a fairly busy screen open right now, and I do have my resolution set so you can see it better. But let me see if I can kind of close some of this stuff off so that we can kind of start from a clean slate here. So basically, when you start in Factory, when you go from our home page, you're going to be in what we call sort of an empty factory. And this is where you're going to start to build your pipelines. This is really the pipeline designer. Okay. And so I'm going to open up the resource pane over here. The resource pane is where all of your factory resources are located. The top level important resources are all listed right here. So let me just go through them top to bottom. Pipelines. We talked a lot about pipelines, right? Pipelines are the sort of the main engine or the heart of Data Factory. This is where everything executes from. So you see I have a bunch of pipelines in here, and I'll show you how to create new ones first, but I think it's important for you to know that pipeline is where you have that control flow. This is where you're going to set the activities that you want Factory to do. So those activities are going to be things like copy some data, move some data, transform data, be able to create loops, if then else conditions, all that kind of stuff is going to be available to you in the pipeline. The next one is data sets. Data sets is very, very important also because data sets are where you define the shape of the data that you want to integrate and you want to transform. And so what that means is that you will define, let me actually open up one of these and I'll show you what that actually looks like. So
Sure.
I have a, let's see, DQ rules over here. So here's a data set that I've defined that is in my blob store. So notice that it's pointing to what's called a link service. The link service is where you will essentially define the credentials and how you're going to connect into that data. And this is where you're going to see all of those different, let me actually do a new one instead of an edit. This is where you're going to see all the different types of connectors that we were talking about. We said we have almost 100 of these. So under new data set, you'll see all these different connectors, and they're all going to be grouped in different categories. This is a list of all of them.
Mm-hmm.
And this is kind of equivalent to what you saw on the doc of all of the different types of connectors. And so there's all kinds of different SQL and SAP and whatnot. It's essentially, in terms of building connectors, we're in what I consider to be the long tail of building connectors, in that we have a lot of connectors for the primary set of stores that you're going to talk to now, and now we're continuing to add new ones that are a little bit less used than others. So the data set is defining, the data set now is defining what that looks like. So this is my DQ rules file. It's a CSV file. And so it's a text limited. It's limited by a comma. So you see it's a comma delimiter. And this is fairly common. So what you do in terms of when you assign properties to files, this is no different than what you would do in many other tools. And then the schema is what defines the shape of that. It's a very simple file with just 4 columns. And you'll notice that the data types in this are all string because it is a text limited. So there is no data type involved. And I will show you in a couple of minutes how you can ask Data Factory to automatically define for you or infer for you what those data types actually are.
Sure.
Okay? So that's data sets. Data sets defining the data that you're going to talk to. Now, data flows, I'm going to reserve this for a little bit later because we're going to jump into this. It's a very exciting area where you do the big data analytics. This is where you do the data lake analytics. You'll do the transformation. All those pieces will be there inside of the data flows. And this is where you're going to build graphs to define what you want to do with your data.
Gotcha.
Power Query is a newer factory resource that we added recently. It's a public preview, and we've updated this in the past couple of months. Now, Power Query will do essentially the same thing a Dataflow does in terms of wrangling data, prepping data, transforming it. It's a little bit more lightweight than Dataflows, and it actually uses the Power Query Online, the web version of Power Query, so that you can perform the data transformations using the Power Query interface if you prefer to do that instead of writing the graph that you see in Dataflows. So if
Very
you like the Power
cool.
Query interface, if you like the Power Query interface, that's a great way to get started with transforming data in the Data Factory. And the last one on here is templates. Templates allows you to be able to take a pipeline that you've created and save it as a template and then reuse it over and over again. So you can use this to sort of define a baseline of what every pipeline should have, and say insist that your data engineers then will create their new pipelines from a template, or you can create templates that are used for an entire end-to-end process and can be shared with other developers. In addition to that, we have a, let me just do this as a jumping off point. We have an entire gallery. So if you click on pipeline from template, the way to create new resources in Data Factory is under factory resources. You click the plus sign, and this will be the new resource dropdown. And there you can see all the different first level resources. And instead of creating a blank pipeline from scratch, you can say pipeline from template. And we ship with Data Factory a set of pre-built templates. So you can see customer feedback analytics, search log analytics, dedupe pipeline, distinct rows, a fact loader, generic slowly changing dimension. All of these are available to you out of the box. In fact, let me just actually open up this one. Yeah, go ahead.
So lots of pre-created and default ways of working with this so that you personally don't have to write out all of this yourself. It's always cool when you see these things like thought about and thoughtful services is the best way to put it.
That's right. So what we've done is essentially given you a way to say that there is a set of existing functionality that I'm going to include in my pipeline, and I don't want to have to start from scratch. Now, you don't have to use these. This is just a way to it's a good way to get started, especially because a lot of really good examples in here. Like I think the dedupe pipeline is a great example. It's a very simple pipeline, but it is a very complex set of transformations that dedupes using fuzzy lookup logic. So a lot of times when you're deduping data in the lake, you're not going to find exact matches. Deduping is not going to be an easy sort of exercise of just saying everything that's exactly the same, take that out, right? It's going to be something you need to use some fuzzy logic in it.
And for our viewers, if you're curious about what he means by deduping, it's looking for redundant data and making sure that things aren't replicated so that when you're doing your analysis, you're working with a single set of data that isn't producing multiple instances of the same information.
That's right. And this entire graph, this very complex graph of doing fuzzy matching, is something you can just click, single click on that template and then get this capability in it. So this graph that you're seeing on my screen, this is the data transformation piece. This is what's known as data flows. And so this is where you're going to work very deep with your data. And this is going to have a set of blocks on it that define what you want to do with your data. So if I want to take this template and modify and do some more things to it, you'll see all the different types of actions I can take on my data. I can join data. Now, joining is in itself very, very powerful because remember, like we said earlier in the talk, any kind of data that you're working with can be included in here. So you could include on the left-hand side your SQL database. On the right-hand side could be your Cosmos DB JSON data, right? So
and if I'm right, Cosmos doesn't do, or MongoDB API in general doesn't do joins, if I'm correct.
Yeah, so these kinds of things like joining, aggregations, whatnot, are usually fairly difficult for NoSQL engines to do. And so what we do in Data Factory is we just connect into the data, and then we simplify it by storing that data in data frames in Spark. And now the data just becomes data. And it's almost irrelevant that it came from a NoSQL store at that point. It's in memory. Cool. It's compressed. It's in the engine. So all of this is working with a Spark engine behind the scenes. You'll see that I have my debug session turned on. And what that means is I'm now working with a live Spark cluster. And I never had to learn anything about Spark or how to set up a distributed cluster or anything of that nature. And that's what, so that's what Data Factory gives you. So let me actually step back, because I kind of jumped the gun a little bit with a template. I got so excited by it, but I'm going to close that one out. You can go back through the tour. So if we go back to the tour, I'm going to close these. We were at the factory resources and how you start with new. So let's just do a new blank pipeline. The primary starting point you're going to have is a pipeline. So you're probably going to say new pipeline to get started. And the tutorials and the docs that Jay was pointing to are very, very good. We work really hard on we work really hard with making those be effective in terms of giving you step-by-step in how to get started with building these. So there's a properties pane in the right-hand side. This is just where you name your pipelines over here, and this can just be any sort of name you want to give it. And then you can put descriptions in there, which I definitely recommend. And then annotations. Annotations are really nice because then you can see the annotations after your pipeline run. Think of it as kind of like a way to tag your pipeline. And I'll show you, in fact, then the end-to-end of a pipeline means that you build your pipeline, you schedule it for execution, and then you monitor it to see how it's performing, and then you can see at the end whether it succeeded or failed. There's also a related tab to show you assets within your factory that are related to that, kind of like sort of a lineage view, if you will, of your factory. All right, so let's build something real simple. So let me actually add onto here. Let's start with a copy. A copy data is most likely what you're going to start with if you just want to move some data around. Now, we've built a lot of rich functionality into copies, so it does a lot more than just moving data, but it's primarily used for that purpose. It's a great starting point to get familiar with Data Factory. And then there's the concept of a source to sink. So this is where those data sets, again, come into play. So you see the different data sets that I have created. And let's do I have a movies database. Actually, it's a movies file. And it's a CSV file. And let's go ahead and open up that data set so we can look at it.
I've definitely played with that IMDb data a bunch of times when I was working at Mongo and I needed like an example data set.
I remember they used that. Yes, it was there. And then we also use a lot of the taxi data and some of the other demos. And these are great data sets to work with. It just kind of gives you a sort of a baseline to work with. And the CSV, and if I do a preview data, you'll be able to go and grab a simple set of the contents within that file. And so everything seems to be there and it looks fine. That's just looking at the data. Now what you want to do then is put it somewhere. So the sink is where you want that data to go. And so a very simple way to just move that is to put that into another folder. So this is simply moving data within the Azure Fabric, okay? And I just have defined a folder. So this data sets, even though it's a data set, it's not really defining any data. It's just saying Blob Store is my link service. So I'm going to put it in Blob Store. And I'm going to put it in this location, which is my container, and then I'm going to use this folder path here. You can browse that right here from the specified path, and you can look to see other areas that you might want to put that data in. But I think that for me, from my perspective, this is fine. I have all these partition files in here. It's such a lot of junk, a lot of garbage is in there, and I think that's where I want it to go. So I'm going to say output/demo out1 is where the data will go. So what happens is in this case, when you just essentially copying data, going from a file into a folder, it's going to move that data there. And then when you're ready, there is a button right here called debugs. This is kind of like the F5 on Visual Studio, if you will. And this will actually just go ahead and execute that. This is all the design environment, right? I'm fully in design environment. There is no footprint required. This is all in the cloud, all in your browser. Okay. But I get that ability to debug. And I can cancel this if I'd like, but I can debug it here. And this is the debug. When we're done, we're going to actually go ahead and save this and publish this. So you see up here, I'm connected into my GitHub. We talked about this earlier in terms of how you connect to your CI/CD and to your repo. So down here, you see that I'm using the main branch. I should probably have a different branch than the main branch, but that's just me. I just happen to be using the main branch. If I were developing something new, I'd make a new branch. And
I get caught with that a lot in demos myself.
I just click new branch here. We actually have it integrated, so you can even do it as easy as saying new branch. Go ahead and do that, and then merge it in, and then publish it. This will simplify the demo. So this was done. This landed the data into that location. Now you can look at the eyeglasses to get details of the monitoring of that execution. So this is the activity that occurred. This was using a copy data. This read this amount of data. It wrote that much data. One file was written. Everything else was essentially automatic. The number of DIUs, or the data integration units used, was 4. This is essentially your knob. Sorry. This is essentially your knob to set how much horsepower you want to give to the process. So 4 DIUs and 1 parallel copy. Go ahead.
So is that kind of like how Cosmos uses, I suppose, RUs to specify like what your total IOPS required is going to be?
Yep, that's right. It's like a unit of measure like that. Yeah, exactly. It's an abstracted unit of measure for essentially the compute that is serverless behind the scenes, which is a great call out because I want to show everybody, I want to show you the integration of runtime as well, which is where that's defined. But yes, that's right. So the DIU under settings for that copy activity, I had it set to auto. That's the auto scale, right? I could come here and manually set that to something else. I could say, I just want to completely blow this out and give it 32 DIUs because 10 seconds wasn't fast enough for me. I want it to be 5 seconds. So okay, I'll put 32 on there to make it faster. You can also set degree of parallelism for the copy activity, which has more impact on things like when you're talking to or from sources that are databases. Sometimes that can saturate your source. So I would just be careful, more careful with that one. This one is more setting the compute size for your copy. So what was very important, and this is a very simple example, but what's very important is from a getting started perspective, I didn't need to set anything up. This is all executed on that serverless compute using the integration runtime. The integration runtime, we talked about this a lot earlier, so let me explain it to you. If you click on the manage section of the UI over here on the left, you go over to integration runtimes. This is where they're all listed and where they're managed. Every factory out of the box will give you this one right here, this auto resolve integration runtime. This cannot be edited. It is essentially part of the factory. And you'll see, yeah, you see there's no configuration in here either. It's really essentially just saying the region to run this in is auto resolve. So when I ran that copy, if my sink was located in a different region, it'll probably make the determination that the copy compute should be stood up and executed from that region. So it has intelligence in it that knows the best path to be able to move that data around. The compute can be utilized within that correct region. That's auto resolve. I could also pin this to a region if I'd rather have no data exfiltration from any region. I can just say pin this directly to East US or whatever it may be, and that will do that. And then if you have your sources and your sinks VNet protected, you would just enable the VNets option on here. And remember, nothing is editable in the auto resolve. This is the freebie that you get. You don't need to build this; it just comes out of the box. This is the default integration runtime. Let me show you what happens when you build a new integration runtime. I highly recommend after you've built a few tests and you want to start actually doing something that's really meant for production or for a real project, is to create your own integration runtime. So just click New. You'll have a choice of Azure, self-hosted, or SSIS. We have not even had a chance to talk about SSIS. This is a whole other topic that we can talk to. The Azure Data Governance team that I represent here. We also have the SSIS and Azure work as well, and that lets you lift and shift those SSIS packages into the cloud very easily using Data Factory, and it uses integration runtime to do that because the integration runtime again is your serverless compute environment. So to lift and shift.
Yeah, sorry. And just for those who don't know, SSIS means SQL Server Integration Services. So that's building enterprise data integration and transformation solutions from your existing SQL source.
That's absolutely right. And so, and there's a lot of those out there. And so a lot of folks who have built those, a lot of customers want to get started in the cloud. And so keeping that investment you have in those packages is a great way to do that. And then you can lift that into the cloud with the SSIS IR. But the other two that we're really going to focus on today is the Azure IR and the self-hosted IR. The self-hosted IR is what you will use to talk to your on-prem sources and to get data off of there. And then Azure is the one we've been using in this demo. The Azure IR is completely ephemeral, completely managed by Microsoft in Azure. With the self-hosted IR, you have to stand up a VM or a server and you install the actual bits for the integration runtime, and then you update that. That's the way that you essentially have a gateway into your on-prem data. But the Azure IR is what we're going to use, and this is what I would recommend you build your own integration runtime and not always use the default. Now here you can say that I want it to be auto-resolve, so use the region that factory determines is the best to use, or if you need to pin that to a region, you can just select the region that you need it to be in for that list. Here's where I can enable VNet.
In the context of like data governance and sovereignty, I would imagine.
Data sovereignty, yeah, because otherwise, now that being said, it's not, Data Factory is not going to just sort of willy-nilly choose a different region. It's going to be based on the link services that you've selected, right? So we know
that makes sense.
Yeah, so your data may be located in West Europe, but your factory is in East US. If you pin this down here to East US, the downside to that is it's going to have to be data going across the wire from East US to West Europe. But that may be what you want. If you use auto-resolve, we would probably make the determination that West Europe is a better place to run that compute. So this is how you get that optimal data movement and data transformation capability in ADF without needing to think about it. This kind of stuff is all sort of handled for you behind the scenes.
Very cool. Hey, we've got about 10 minutes left, and I want to make sure that we get to some of the questions, and I'll let you continue this, but I want to pop in one. Eric was really nice enough to ask, although I'm in an enterprise, and this may not be a concern, for those non-enterprise customers, would those explorations of pipeline templates be billable events prior to commitment? So I guess before you're actually saying, yep, I'm going to take this on and pay for it.
Oh, in terms of being billed for using Factory, is that the question?
I think so.
The templates are really just anything that isn't assets within Factory is you can build those and you can design those, and there's not a cost associated with that. The cost comes when you execute things. And actually, it's a great. It's actually, to be honest, if I just spend 1 second on this real quick, it's a great segue because the monitoring is where you're going to go to see what you ran, whether it succeeded or failed, how it performed, and the cost. Okay, so there's actually a consumption report output right here. When you click on it, you will see the number of units. This one actually had 0 units. That's not a great example. Maybe this one will have more on it. Yeah, I don't have any great examples.
Oh, and you've got that pricing calculator, so you're getting real-time information about what exactly you've used and what you've spent.
Yeah, that's right. So that will, while we go through the rest, I can always see if I have others that are lined up. But yes, the pricing calculator will then let you grab the units that you see in the quantity there. Let's see if I open it up here, if it has it here. And then that will give you the insights into how much was being billed for it. And just saying create pipeline from template will not be an event that would generate a meter for that work at all.
Very interesting. So we got about 8 minutes left in the show, and I was curious if there's something you'd like to show me still, to kind of take a look at what's next.
Yeah, let me finish up that discussion we were having on the integration runtime, because the other area of the integration runtime that you're going to want to set up and think about is your data transformation piece, and this is a separate set of compute from the data movements piece. The data flow, the data transformation uses the Spark environments for that. And what you'll see is a way to set the different size of the compute, the general purpose memory optimized. We don't recommend compute optimized for production environments, but if you want to get started, you can always play around with that one. General purpose is usually a pretty good way to start. And then you can set, just like you can set the DIUs or the any kind of unit for other services in Azure as well, you set the core counts with the integration runtime for your data flows. And so you can grow this as your business and your data grows as well here in the integration runtime. And again, this will spin up the appropriate compute size for you in the background without you needing to worry about that. We don't have to stand up
don't have to manage those VMs or something like that. It'll all be handled for you as a service. And I would imagine when it's done and you're not using it anymore, you're not being billed for it.
Absolutely right. I'm in the wrong area. Let me just go over here to my resource. I think we'll do, let me show one more thing here. So this is the pipeline piece. Now, when you dig into how you would actually transform that data, you've moved the data into a place where you need to have it in a staging area, or you want to work with that data, you'll add a data flow then. So to kind of complete that last flow, I'd probably have a copy activity before these data flows. I would connect with a connector line into my data flow, and then this would be sequential. This would go copy data, taxi demo, and then update taxi. If you don't put a connecting line between the two, what happens is it will essentially just run in parallel. These two will kick off at the same time, and then the third activity would execute. So I'm going to connect those two.
Drag and drop, point and click kind of method of doing it. Very cool.
Yeah, absolutely. This is the whole concept here, is to be able to do this stuff quickly and easily, and be able to visualize easily what it is that you're trying to do within your code. So let me go into the taxi demo real quick. I'm going to double click on that. And this is going to show you how to work then with the transformations within the data flow piece. Let me expand this just a little bit. Now, this also has a source and sync concept, just like we had in the copy activity, where I'm pointing to, in this case, a taxi fare data.
Mm-hmm.
But now you're going to get a little bit deeper with the data. You're going to really start to introspect that data a lot more than moving the data around. So we're going to have things like projections. And now look at how Dataflow is able to automatically detect data types. So this was a text limited file, but because we have this detect data type feature, it'll go and sample the data and will tell me what the data types are. So I didn't need to set any of this. It knew that based on the contents of the file, these should be doubles, these should be timestamps. And then the next thing I'm going to do is I'm going to take that and I'm going to join that with another source. Let me just make that a unique name. There we go. So this join is now going to take this taxi source and this trip source down here, which is a different set of taxi data. Going to perform an inner join on those with these different columns in it. And the way it's able to do that is we have all of the metadata stored about the files or the tables or whatever it is that you are transforming is stored within the browser. So this inspect tab here will give you all that information. Here are the data types. This is where it's coming from. This is what's being used inside of that join. So the richness of working with data at this level is part of the scope within the data transformation piece. And then at the end, what I do is I land it in what's known as a Delta Lake format. So when if you're going to work in that data lake environment, the Delta Lake format is it's a very convenient way to store that data, because here's a really cool thing. When I land that data in my sink, I have this setting now where I can actually say update that data. So these are stored as Parquet files in the lake. There's no database really involved here, but I can say delete, upsert, and update, as well as insert. So you get essentially database capabilities. Yeah, database capabilities. But in fact, if I say updates, it's going to ask me for things like, it's going to actually ask me for whether or not I have a key column for that. So the key column essentially is really a database construct, but it's being brought to you as a data lake user. So if let's say maybe it's a composite key. So if these two columns made up my composite key, I can select these in the UI, and now my Parquet files in my folder in the lake will be able to be updated. I can update rows, I can delete rows, and it's all done through the Delta Lake mechanism.
Great. So, Mark, we're down to our last couple minutes. And before we finish up, Christos, who was actually on the show recently, had a question. He was curious if there are any feature parity limitations between Data Factory and SSIS that we should be aware of.
That's a great question. So I would say that there's probably a few, but most of those might be actually intentional, just because Factory has a slightly different orientation to it. It's cloud first. It's a platform service. It's browser based as opposed to being based in Visual Studio, and primarily SSIS is a SQL Server, primarily a SQL Server tool. But if I think off the top of my head, there really isn't all that much. There's a few things in the control flow side. If you look at the pipelines, the containers are something that you don't see within Data Factory pipelines. However, we do have the ability to have things like you can have lookups, you can have if then else, loops, those sorts of things. Those are stored here under those are iterations and conditionals. There's a few of those kind of control flow things that aren't there in SSIS. And then SSIS has a really rich partner ecosystem that create a lot of add-ons, DDL add-ons to SSIS that won't work, obviously, and aren't part of EDF.
Very cool. So we're just about at the end, Mark, and I want to give you a chance to let everybody know where they can find you online. Just want to remind everybody we had a poll today, and it looks like the better portion of you who answered are registered for Build. And if you're not, go ahead and register for Build. It's going to be a great event, and I'm looking forward to it. So, Mark, thank you so much for being part of this today. I really appreciate it. We're just up out of time. And where can people get in touch with you if they'd like to talk to you more about Data Factory?
I think the best place to go is Twitter, and my handle is at Kromer Big Data.
Very
And
cool. It's right there at the bottom.
there you go. And definitely hit me up anytime on there. Happy to chat with you there.
Awesome. So, Mark, thank you so much. I really appreciate your time. And next week, one of your teammates, Abhishek, is going to join
Yeah.
me for the second part. And we'll talk a little bit more about security and working with that within your data. So let's give everybody the great big goodbye and a wave goodbye. And we'll see you next week. Thanks again, Mark. Thanks for watching Azure Fun Bites. Take care.